All right, my name's Jamie Burse. I work at Jorn, or on Jorn. This is more of a sort of a not so technical. You can ask me about that later. I'll talk that forever. So just talking about our use of some clustering, mainly reliability. So background, Jorn high frequency radar system used all over Australia. There's 3 major sites and a command and control centre in Adelaide and also a development site. But we're really concerned about the operation of the radar, not the toys we get to bring in later. And of the operation, our KPI of 90% uptime of tracking a target is what we're trying to get all the time. And we want to get under that, otherwise there's lots of contractual fines from the customer for it. And when we look at the radar, we try to think of it as more of a jet fighter, because it's like at Mach 2, there's no help desk. The guys out at the actual operational sites, there's no admins. They're technical guys. They're mainly concerned with hardware. They do run up the system and they do all their tests every day, and they could probably, desolder your whole computer and everything there and put it back together. But there's no like Linux admins or True64 dedicated admins. So they are our remote sites. So back at the SPO end, the end where we do our design and engineering, there's lots of engineering, lots of config management, which all gets deployed to sites, and nothing gets deployed out there that hasn't gone through tons of testing and being signed off by 2 contractors and the DMO and the RAF. So there's lots of big people involved. And there's also the training and documentation side and just tools that the guys up at site have to use. Hardware is pretty standard now. Lots of HP, DL380s, DL360s, workstations. But all our clustering's on the DL380s, mainly just 2 of them. Just some engineering timelines there. 3 years for the first one, Red Hat 7.3. We're now end of life, so by the time it actually gets deployed, all that, there's no extra support. Then we went to RHEL, which was good, using DRDB and Heartbeat, and that worked really well. It was actually a really neat hands-off install. Everything's hands-off install is what we do. And you could fail over and you could fail it back very easily. And it was easy for the guys up at site with all the documentation stuff we'd done to be able to manage it. 5.6 is just all the processing nodes. And then 6.1 came along. We did that only for the servers. And we thought it'd be great to have DRDB and CoroSync. And we thought as the admins or the guys back at the development site, this had some, lots of potential for other applications rather than just all our files and services that we've got to provide to all the nodes. And it was, as you see, it's very quick, 6 months, which turned out to be a detriment to us in the end. So our components when we deploy, it's basically a Red Hat deploy, and then there's a bunch, up to 650 scripts and config files that may have to get read to finish your builds off. All builds are automated, even the CoroSync ones. So the guys at site, when they install stuff, they use a USB key for the first server, and then that will be set up for CoroSync, and the second one has to get set up and at the end, and they sort of play together. You can't just build one off by itself. So, yep. So, what have I got there? Yeah, so we're mainly concerned about data and quite a few services. Yep, there's our basic Red Hat 7.3 ones, bit of rsync. RHEL 4.7, this was good, easy to manage and fault find when it did break. 5.6, not clusters. 6.1, our trial, we even had a trial deployment of this, and this is where we had some, if everything could go wrong, it would go wrong. It came down to just being hard to manage, and the guys, when it got deployed, we didn't have all the tools out there and all the documentation that they could use to get it back and going. And when if you can think of some more funny memory problems you want to run around with, like hardware memory problems at the same time you're deploying this, that all fell into place as well. And the guys out there have complete confidence in what you deploy. So if it doesn't work, they just keep trying to switch things back and forwards. And they couldn't keep that 90% uptime going. And this wasn't a critical system at the time, so it was a trial deployment at one of the sites. That was actually down at the command and control one. So we didn't have enough diagnostic scripts for them to run. We'd started that, but like that short engineering timeline was too short to get that up and going. We had looked at some of the GUI tools that were out there, because that's what we'd like our guys, lots of big red flashing stuff. So things that would point out to them really easy, what's broken, what's to fix, what script they might have to run or command they might have to run to fix the problem. And so in the end, after this one disaster, and all the managers and engineering managers and just went, no, this is too hard for them at the moment. And we fell backwards. We took like multiple steps back now. So we went back to 2 servers are syncing certain data. And it's really just a manual failover script. So when one box totally dies, which is our main concern, it's just turn that off and run a script on the other one to suck up the interface and get it going. Let's see what else. So we had lots of lessons learned from this. So lots of stuff that we learned, and we're meant to take this in on the engineering side and then push it back out. So support tools. So us supporting those guys out at the site is the most important thing. Doesn't matter if we have the best solution, which we thought it was, and we still want it back in there. We've got to have the tools to support those guys. I know when we were looking at some of the GUI tools that were out there, that was 18 months ago, so we can't keep looking at things. We have to look at the tools at the time as the project starts, and then we get cut off. So yeah, and it just means with your whole project, we need better risk analysis. And this would have been a project like the other ones where you had a full engineering life cycle. RHEL 6 was chosen right at the end due to some extra features that RHEL 6.1 had that RHEL 4 or RHEL 5 we were going to stay on. But yeah, we kept with RHEL 6.1 hoping that later on CorrieSync will come back in with DRDB. And even just before I left, there was a project I was finishing off with some guys, which would have been really cool to have DRDB and CorrieSync going. And that was more at the application level, which would have been really good. So we hope to get back to DRDB and CorrieSync. We really got to find the tools or write the tools ourselves if we can't, that we can get the guys to fault find when things are timing out or servers aren't coming up and they can't see what's going on the screen. It's really bad. You know, you get the one where the disk wants an FSCK for some reason after a failure. You know, it's either counted or it's been too long up, which is usually the thing, it's just been up for so long. And they miss it, and then CorrieSync fails on us, or DRDB. Yeah, and that's it. The tools have got to be for our non-Linux admins. So the guys who use the computers every day, and they run up the radar, they run all their tests, they know how to fix everything, but all the things that can go wrong are usually documented. It's a very big Air Force military thing where everything has to be documented to the nth degree, and they don't like any surprises, which that's what CorrieSync really gave us. I mean, we loved it back at the development site, but yeah, just when it hits the actual operational side, it was just a bit too much for everyone else to, it was too much to absorb in too short a time. So, any questions?
You can spend a lot of time reading logs.
Yeah, that is, and that's like, we had some really good, one of the guys who did the actual development of CorrieSync and that, and DRDB, he wrote a really cool PowerPoint presentations, and he had some really good documentation. But yeah, reading logs, when it says in there read logs and they're enormous, if you don't have even the right grep commands for people to run to filter out all the stuff you don't want, it's going to confuse them. And at a time where, they're going, come on, someone's jumping on you to have this system back up and running. It was...
And that can be tricky too, because you'll have a failure down here somewhere, but the root cause is several pages up there, and unless you know...
Yeah.
Yeah.
Yep. So yeah, we had lots of fun. But I mean, yeah, and we could really use it back in. We just got to get those tools. So if anyone knows of some real cool, front-end GUI tools to tell you all the CoroSync problems, they're out there now.
Should probably plug the one I'm working on, but I don't have rel builds yet. So.
Yeah. So we're using rel now, but we're also looking at clones as well. So Scientific Linux is one of our favorites. Yeah.
At the risk of ticking off every single Red Hat person in the room, why exactly did you choose the distribution that among the enterprise distros probably currently has the worst support for both DRPD and the CoroSync pacemaker stack?
It's just, the history of it. So you saw back there, we started with Red Hat 7.3, and there was nothing. And we have a tendency to keep following it. So at the time, we had this build that worked great thing on 7.3. Went to rel, all our kickstart, and all our scripts just worked straight away. There wasn't a big development, whether we went to SUSE or Debian or something. People saw that the lead-up time to change everything to a different build system was maybe a bit too expensive for them to do. But yeah.
There is some stuff in the CRM shell as it ships on SLES anyway, which lets you do some history analysis. So if something's broken, it'll actually go and get the log files for you and interpolate them and show you hopefully the relevant bit with the right information. So there's stuff going on there in the CRM shell upstream and on SLES, but not so much on Red Hat. So I'll stop at that point because it behooves me to be polite, so I will.
Yeah.
Do we have any other questions?
It might be worth your while poking the webmin mailing list, because my guess is that if this sort of thing was to happen, that's the most likely place it would happen. Not suggesting it has, but you mention it enough times and someone might go, yeah, I'll write that.
Yeah, I think before I came, I was once again looking at some of the GUI tools that are out there and saw some videos, but the way we deploy might be different to a lot of other people. Like when we first looked at CoroSync, it was like, you got to install a server and another server and then apply your CoroSync. But ours is all hands off. So you install the first server and you do that initial CoroSync setup, and that then kicks off the second server build. And then at the end of that one, it then has to tell the first server to finish off its setup. It's just because of the sites. It's really the support of those remote sites, which they're more like mining sites. They're at Laverton and Longreach and Alice Springs. And then they're outside of that as well. They're like, keep driving a couple of hours if you don't hit all the kangaroos and everything. So, yeah.
Could you use Gluster or anything like that?
Oh, yeah, we would like. I've seen a few things. Even. There's a few other things I think we should look at maybe. DRD worked really well, and it's still actually running on a 4.3 boxes. So like all those OSs are still running. That's the other thing. We keep all these things going all the time. Yep.
So is it just purely file data you need to have replicated, or was there a need to actually replicate the actual block device in regards to like the Gluster question?
Yeah, it's just files. I think we found DRDB just to be good, because we usually have, servers are very basic setups that we have. DL380's, you've got a couple of system disks mirrored for your OS, and then just a massive, like 11 terabyte at the moment, RAID 5 set, or it could have a few hot spares, and that's getting bigger again for some of the databases. Or they're different again. We've got Oracle databases that are getting bigger, but they're not using DRDB, of course. But but like I said, it's really files. They can be huge files as well. So some of the rsync stuff can be really, you've got to watch it, because it will either take too long. You can't do checksums, things like that, because it will take over 24 hours to replicate the data if there's a lot there, and then that kicks off another rsync, and you just fall into another screaming heap and watch your system slow down.
We're not quite at afternoon tea yet, but if there's no more questions, there's one.
Have you seen much of an increase in the IT literacy of the operational staff as the years go by?
At the sites, I think yes, they are, but because they're so concentrated on supporting the hardware that they're at, like the guys at site, they work in 12-hour shifts. You know, they're out there 2 weeks on, 2 weeks off. That's why I say it's a lot like a mining camp, very remote. You know, they're not like us that just want to keep absorbing every bit of IT stuff that comes past. And when you're not at work, you're working on your own stuff at home. So yeah, and they don't have up there, they don't have spare systems. There's not a lot of spares where they can go, right, we're going to have an extra couple servers over here, play with installing them and putting data on them and trying to break them. They don't have that, you know, that extra hardware up there to do it. I mean, they're pretty amazing sites, some of these, you know, custom built sites, but yeah, they don't have those extra tools or training. You know, that's it again, training coming up that it would be really good. And it's hard to send those admins or some of the senior people up there to stay up there a long time because you've got that 2-week shift and they're all sort of, you know, staggered. It takes a long time, and just a once off, you know, is not enough. You know, and you get different people. Like I said, you get different people. Some people just want to soak it up and keep doing, you know, using it. But yeah, they're keeping the radar operational is their, you know, one main thing. They got to, you know, that's it. That's their job. Sitting up there trying to learn stuff is a bit harder. There's no time.
If there's no other questions, thank you, Jamie.
Cool. Thanks.